Hello guys, so welcome to our channel once more. Oh, we've missed you so badly. Screen time, it's really swamp season at KC, and summer holiday classes are coming up. We're trying to produce books and pamphlets for these guys so that we can hit our expectations of the points we want to get this year. Yeah, our mission has always been inspiring a generation of scientific and creative thinking global scientists, and make sure you stay curious, right? You want to contact us, our email is right there rolling on the screen, and reach out to us, contact, shoot us a message on WhatsApp. Thank you so much. Let's dive right in. All right guys, so very quickly, expression partial fractions, this becomes, all right, so we want to just quickly write that down, and then of course in partial fractions we would have, since we have x minus 1, we have a over that, then we have a non-reducible quadratic factor here, we have bx plus c over that 1, so cross multiply by this denominator here, x minus 1 to x squared plus 1, so you actually multiply, you would have this, and then now you can actually just equate coefficients, right? And then you get the values of a, b, and c. So when x is 1, I've decided to eliminate. When x is 1, your a is just directly 4, and then you equate coefficients of x squared. You actually realize that a plus b will be equals to 5, right? So that's the coefficient of x squared on the right hand side. So you actually have b to be 1, and then come over here, and then we equate constant terms. You actually have a minus c to be 3, and then our c is 1, right? So you realize that in partial fractions will be 4 over x minus 1 plus x plus 1 over x squared plus 1, which gives us the answer to be B. Given that the polynomial x cubed plus 4x squared plus 2x plus 1 and x cubed plus 3x squared minus x minus 1 leave the same remainder when divided by x minus 1, the possible values of m are, alright, so we just want to call these polynomials names, right? So we actually have f of x, which is this, and then the second guy would be g of x. And then now what we want to quickly do is, of course, we want to use the remainder theorem. So if you have a linear divisor like this, right? So x minus m, the remainder this divisor leaves when it divides a polynomial like this is basically f of m, right? So we actually have f of m equals g of m because they basically have the same remainder. They basically leave the same remainder when divided by this divisor. So you actually have a f of m, you put m there, and then you actually have m cubed plus 4m squared plus 2m plus 1, and then you get g of m, which is that. Now since f of m is equal to g of m, you take 1 minus 2, you realize that f of m minus g of m actually gives us 0. So you actually have m cubed minus m cubed, it goes 4m squared minus 3m squared, we have m squared here, 2m minus m, so we have 3m, 1, so we have 2. So you actually solve this quadratic equation, factorize m plus 1 into m plus 2, and then you actually have m to be negative 1 or m equals to negative 2. So our answer is D. The range of values of the expression 2x over 1 plus x squared, x belonging to is, all right, to get the range here, you just want to make that expression to be y, all right? So you actually cross multiply, and then you have this. Now you realize that this is a quadratic equation in x squared, right? Or in x. So we want to do is that since x is r, let's just rearrange it a bit so that we actually have yx squared minus 2x plus y equals 0. So this is your a, this is your b, and this is your c, right? So now if for all x belonging to r, like here, you actually have b squared minus 4ac greater than or equal to 0, right? As a condition for real x, right? So you actually have b, what's our b? We come back here, our b is actually negative 2, we square that minus 4a, our a is y, our c is y. So you actually have y squared minus 1 less than or equal to 0, right? So let's solve that inequality. We actually have y minus 1 into y plus 1, which is less than or equal to 0. So we'll come over here, and our critical value is y equals 1 or y equals negative 1. So since the inequality is actually less than or equal to 0, and then y basically just lies between those critical values, negative 1 and 1. So hence y is that, right? Because it lies between negative 1 and 1, so close interval from negative 1 all the way to 1, close interval. So our answer is A. If the roots of that differ by 1, then okay, so let the roots be actually alpha and alpha plus 1. So a student can actually say alpha and alpha minus 1, right? That would be still correct. That would still be correct. So sum of roots would actually be alpha plus 1, which gives us 2 alpha plus 1, right? But sum of which is actually negative beyond a, so we actually have just k there, right? Because your b is k, and then your a is negative 1, so negative beyond a actually makes that k. So you can just go on and get alpha here. Alpha is actually k minus 1 and 2, right, from this equation. So product of roots is actually we get these two guys multiplied, alpha into alpha plus 1, which gives us alpha squared plus alpha, right? But it's actually C on A, so our C here is -2, A is -1. So put 1 in 2, you actually realize that we'll take this value of alpha and put in here, so we actually have k minus 1 on 2, all that squared, plus k minus 1 on 2 equals 2. So you simplify that, and then you actually have k squared minus 9 equals 0. So there's actually no answer here. So I think this is one of those questions where you don't have an answer. So just, you know, have to be confident, and then you move on, right? All right. The value of x for which this equals 0 is, all right, so again, that's just an equation, so we write that equation out, and then what we really want to do is realize that this exponent here is actually negative, so once just multiply all through by e to the positive x, right? So we actually have e to the power 4x minus 3e to the 2x, right, minus 4 equals 0. So you can actually factorize, right, because you actually have e to the 4x here, and then you actually have e to the 2x here, right? So you actually realize that this, you should technically want to look at it, this guy is actually e to the 2x squared, right? So you have to let e to the 2x to be t, and then you actually have t squared here minus 3t minus 4 equals 0. But then I've just gone ahead to maybe factorize. So you actually have e to the 2x minus 4 into e to the 2x plus 1 equals 0. So our e to the 2x is actually, you know, 4, because there will be no real value for this guy, right? Since ln of a negative number does not exist, so this guy, forget about it. So you just focus on this guy, and you actually have your 2x to be ln 4, your x 0.5 ln 4. So our answer is B. If log 2 base 6 is 8, then log 3 base 8 is, all right, so you just have to follow up with the simplification I've done here. I hope you try it out your own way, or maybe some other different way, but this is the way I simplified it. So we have log 2 base 6 to be a, right? So we actually realize that we can rewrite this logarithmic expression, right, by just simply changing the base. So we want the base to rather be 2, and then, you know, get 6 up. So we actually have 1 over log 6 base 2, right? So equals a. Now we can actually go over, and then you realize that this log 6 here, right, 6 is actually the same as 3 times 2. You know that log ab is the same as log a plus log b. So this log 6 is basically log 3 base 2 plus log 2 base 2, right? A. Perfect. So you come down here, log 2 base 2 is actually 1, right? So we actually have 1 all over 1 plus log 3 base 2 is a. Now we actually want to make log 3 base 2 our subject, so it's actually 1 minus a over a, right? So now log 3 base 8, we can actually write that as log 3 base 8 is 2 to the power 3, right? So now we come over here, and then this log 3 base 2 to the power 3, we can actually take this power down. Remember that if you had 3 raised to the power n here, for instance, so if you had log 3 raised to the power n, you can actually bring that n in front. So if the power is rather in the base, you can actually bring the base in front, but you have to reciprocate it. So I've actually brought the base in front, but I've reciprocated it. So you now have 1/3 log 3 base 2. Now log 3 base 2, again, from this expression is 1 minus a over a. So you just simply put that there, you actually have 1 minus a over 3a. So our answer is A. The solution set of the inequality x plus absolute value of x minus 2x absolute value of x minus 8 greater than 0 for x belonging to R is, okay, so absolute value function. So we can actually always solve these guys by just going by the domain, you know, the basic mathematical definition of what an absolute value function is. So an absolute value function of x is basically just x for all x greater than or equal to 0, or it's negative x for all x less than 0, right? So we actually have when x is actually greater than or equal to 0, so we can actually solve this guy based on this definition of what an absolute value function is. So when x is greater than or equal to 0, we want to come in here, wherever I will say this guy, this absolute value of x will just be positive x, right? Because we've actually said that absolute value of x is x for all x greater than or equal to 0. So when x is greater than or equal to 0, this absolute value becomes x minus 2x. Now in this place of this absolute value again, you actually put another x, so you actually have minus 2x squared there, right? Minus 8 greater than or equal to 0. So if we simplify this guy, we actually have x squared minus x plus 4 less than 0. So you realize that this guy is actually, you know, this is a quadratic function that with a complex root. So it actually has complex roots. So of course it does not belong in R, right? Because the question says we should solve this in x, well, for x in R. So we can go on and then say, what about when x is actually less than 0? So if x is less than 0, wherever we see the absolute value function, remember that you actually put negative x. So you come over here, you have x minus 2x, and then in this absolute value function you put minus x again. That's why I'm putting minus x here, minus 8 greater than 0. So you actually have this, and then you actually, you know, simplify. You have x minus 2 into x plus 2 greater than or equal to 0. So solving that inequality, you actually have x greater than 2 union x less than -2. So since this absolute value function is gotten for values of x less than 0, right? So we would actually reject this value of x that is actually greater than 0. So we'll just take the guy that is less than 0, because the absolute domain of that function was, of this particular solution, was actually x less than 0. So our true value here is just x such that x is less than or less than -2, and that answer is C. The graph of y equals this, x belongs to arrow, is first reflected in the y-axis, then translated 3 units parallel to the x-axis. The equation of the graph obtained is, all right, so how do we actually reflect, if we get y equals to f of x, right? How do we reflect a graph about the x, it's reflected in the y-axis? Good. So how do you get the reflection of a graph about the y-axis? All right, so that reflection is basically f of -x, right? So reflection about the y-axis is actually f of -x. So what about the reflection about the x-axis? Reflection about x-axis is basically negative f of x instead. Okay, so we actually have f of -x there for the reflection about the y-axis. So f of -x would actually imply that we get -x, and then we put whatever we see x in f of x, right? So we actually have this. So the reflected graph about the y-axis becomes x squared plus x plus 5. Now f of -x, let's just call that g of x, right? So g of x now is the reflected graph, right, or the reflection of f of x, right? So we actually say that g of x, all right, so we actually want to translate that reflection now 3 units parallel to the x-axis. So if you want to translate that reflection 3 units parallel to the x-axis, what translation actually means is just you're moving a particular point on that graph 3 units maybe to another point on the x-axis. That's really what that really means. So you realize that I can basically do that translation by finding g of x minus 3, right? So that's me translating 3 units parallel to the x-axis. So let's find g of x minus 3. We just carry that g of x minus 3, and then we put back in the reflected function, which is g of x. So we put that, we have x minus 3 all that squared plus x minus 3 plus 5. So we actually have that reflection to be base simplify, and then you actually have that reflection to be and the subsequent translation to be x squared minus 5x plus 11. So our answer is actually B. The sum of the first n terms of an arithmetic sequence is 187, given that the first term is 8 and the n term is 32. The value of n is, all right, so the sum of the first n term of an AP is actually just n over 2 to a into 2a plus n minus 1 times b. So you can actually rewrite that as n over 2 a plus l, where l is just the last term, right? So I'm going to use this because they've given us the last term. So the sum of the first n terms is actually 187. So how do I get that sum? Is actually n over 2 into a. They're giving you the first term to be 2 plus the last term is 32, which is basically the n term, right? So you actually realize that we can just simplify and then get n to be 11. So our answer is B. So for odd values of n, so the sum, that particular sum is equal to, all right, now I must admit I got stummed a bit here, so let's just analyze it in a bit of way, and then I'll actually show you variants of the question, because I actually analyze the question for even n also, right? So I'm just going to do this in this particular session. So we actually have, let's just get a few terms of this particular series. For the very first term, when r equals to 1, so you actually have -1 here multiplied by 2 plus 1, which gives you -3. And then for the second term, your arrow is actually 2, and then you have -1 squared, which is just 1. Then you actually have 2 times 2, which is 4, plus 1, which is 5. So yeah, that's your second term. Then you can go on to the third term. So you actually have this alternating sequence of terms, right? So you actually have -3 to 5, and then to -7, and then to 9. So yeah, this is basically a series of alternating odd numbers, right? So what we can actually analyze here is that if I get these first and second terms, if I sum them, I actually have a 2. If I sum the third and the fourth term, I have another 2. If I sum the fifth and the sixth term, I have another 2. Now, what if we decided to sum only the first 2 terms? We would have just the 2. What if we decided to sum the first all the way to the fourth term? We would actually have this 2 plus 2, which gives you 4. What if we decided to sum the first all the way to the sixth term? You would actually have this 2 plus 2 plus 2, which gives you 6. So you realize that the sum of the first n terms, provided that you are actually using r to be even. Okay, now just take note of what I'm saying. For this first value, your r is actually odd. For this second value, which is positive, your r is even, right? So for this third value, your r is odd. Your fourth value, your r is even. So if I get a pair, if I get the first n terms, if I sum them up, I'm actually going to have n, right? That sum is just going, it's basically just going to be n, as long as n is even. But in this case, they've told you that n is odd. So I actually have to get the sum of the first n minus 1 terms. Then the sum of the first n minus 1 terms will basically just be n minus 1, because the sum of the first 2 terms is just 2. The sum of the first 4 terms is just 4. The sum of the first 6 terms is just 6 from here, right? So if I get the sum of the first n minus 1 terms, because that's the last even number for r, you realize that it will just be n minus 1. Then now I would have to now add the last term to it, which is just the nth term. So that's what I've actually done here. You actually have, what if we want to get r to be n minus 1? Put n minus 1 here. Because r is odd, n minus 1 will be even. So this negative 1 here would actually be positive. So you put n minus 1 here, you actually have 2 into n minus 1 plus 1, which gives you 2n minus 1, which is this term. Are we there? And then your last term now would basically be for r to be odd. So you realize that this guy here would be negative, right? So you actually have this negative 1 here, and then 2n plus 1, because n is odd. So you actually have this is your last term. So if I sum all the way to this n minus 1 term, that sum will just be n minus 1, right? So now to get the sum of that sequence, I'll basically have that n minus 1 plus that last term, which is negative 2n minus 1. So that gives us, of course, negative n minus 2. If you sum these two guys, you have a negative n minus 2. And your answer is, so we can actually just factor out that negative here. So you actually have negative 1 into n plus 2, so that it matches directly with D. Now, so the answer here is actually D. What if we just went ahead and then said, what about for even n? Now, for even n, we would rather get the sum from r equals to 1 all the way to n of negative 1 or to the power r to r, because to r then you'll be summing even numbers, right? So you get a few terms like this: negative 2, 4, negative 6, 8, negative 10, 12, and so on, all the way to the n minus 1 term and then the n term. Now take note that if I get the first value here, which is for odd values of r, and then I sum it to the second guy, it would actually give me a 2. The next will give me another 2. Sorry that it is not here. And then this next will give me another 2. Now take note that the n minus 1 and the n term will sum up to give me another 2. Why is that? Because the n term is already even. Remember that this for even n. So if I'm summing and for odd r and even r, it gives me a 2. So the last two terms will be odd r and even r. So these last two terms will just basically be the n minus 1, the n term. So because the first and the second sum to give 2, the third and the fourth sum to give us 2. So if I sum the first to the fourth term, I'm actually going to have 4. If I sum the first to the sixth term, I'm actually going to have 6. If I sum the first to the eighth term, I'm actually going to have 8. If I sum the first all the way to the nth term, I'm actually just going to have n. Perfect. So our answer here is D. And then for the sum for the even numbers, so it would just be n, right? So sorry that I took a lot of time here. I just needed to show you that those cool things. All right. The number of permutations of the letters of the word contemplate in which the vowels are together is, all right, so we just want to write out that word and then get all the vowels together. So you have O, E, A, E here, and then all the consonants together, C, N, T, M, P, L, T. So how many ways can you get this arranged? Now watch, how many letters are there all together there? Now if I'm getting these guys together, it means that these guys are not, they act now like a single letter because they always are together, you understand? So we have how many consonants? 1, 2, 3, 4, 5, 6, 7. Then these letters that are always together, you are now group them as 1, so you actually have 8 letters. So to arrange these 8 letters, you actually have 8 factorial. But is anyone repeating? Of course. Look at these t's are repeating, so you have 8 factorial over 2 factorial. Now that's how you arrange these letters normally. But you come inside these vowels, right? I can also arrange them too. It must not be O, E, A, E. I can actually arrange these vowels. Though they are together, the order of arrangement actually changes. I can actually have E, E, A, O, or O, A, E, E. You know, I can arrange them in so many ways. So how do I arrange these vowels? Now, after I arrange the general arrangement, and I'll come inside and then I arrange the vowels. So and actually means multiplication. So we actually have, there are 4 letters, there are 4 vowel letters, so we actually have 4 factorial divided by, how many of them are repeating? E is repeating, so they're repeating twice. So you actually have 4 factorial over 2 factorial. So this 2 factorial times 2 factorial is basically just 4. So this 4 factorial up here, I can actually make it as 4 times 3 factorial. So this 4 down here goes with that 4. So I have 8 factorial multiplied with 3 factorial. So our answer is C. Now, an interesting question would be, how many ways can you arrange this such that the vowels are rather separate? Now, let's come over here and analyze that. If you want to get the vowels separate, now students are tempted to think that you just get the number of normal arrangements, right? Arrangements without restriction, minus the number of arrangements where the vowels are together. That will give you the number of arrangements where the vowels are not together. Well, that's wrong if you do that here, right? Because if you actually get the number of natural arrangements minus when the vowels are together, which is just this arrangement, you realize that this is when you're assuming that all 4 vowels are together. But when they say when the vowels are with the vowels separate, it means that O and E should not even be together. So if you subtract just this guy, it means that you're only subtracting one of the possibilities where the vowels can be together, where there are all 4 of them. All right, so how do you do that then? Now you have C, N, T, M, P, L, T as your consonants, and then normal way of arranging these guys would be 7 factorial over 2 factorial, right, which is 2520. Now these are our vowels, right? We actually have 1, 2, 3, 4 of them. Now there are 4 random selections. There are 4 possibilities. There are 4 vowels to be arranged in how many spaces? Look, 1, 2, 3, 4, 5, 6, 7, 8 spaces. Right? So each point where you see this dot is a space where you can put this vowel. So I can actually put the vowel, I can actually pick any one vowel and I put it here, put another one here, put another one here, put another one here, or I put it here, put it. So there are so many ways I can arrange these vowels along these positions. But now this is a set of items that I want to arrange in positions, right? How do I do that? Of course, I have to do that with permutation. So I would now have to say I want to arrange 4 things in 8 different positions. Is it 8? Perfect. So that's actually 8 permutation 4. So I get my normal arrangements of arranging these consonants, right? Because these consonants I can actually have C first or N first or whatever. So I now actually have that normal way of arranging the consonants, which is 2520 multiplied by the number of ways I can now arrange these vowels in these positions in between the consonants, which is just 8 permutation 4, right? So that gives you 4,233,600 ways of arrangement. But if you actually just normally took that arrangement like I was explaining before, a student who just takes the normal arrangements without restriction minus when they are together, you realize that that gives you about 7 million. It gives you so many more ways, which is not true, right? Yes, yeah, that's not true. All right. In an examination, a candidate has to answer 8 questions out of 10. If he must answer the first 2 questions out of 10, if he must answer the first 2 questions, then he can choose the 8 questions in. All right, this is very simple. The first and the second are actually a must, right? It's not like you're picking 1 question out of 2. Listen, if your question said the candidate must pick 1 question out of the first 2, that's a different question. How many ways can you pick 1 question out of 2 questions? 2 combination, 1 ways, right? But here you're actually picking 2 questions out of 2. The first 2, you must answer those first 2. So there are only 2 combinations, 2 ways you can actually answer 2 questions out of 2, right? Which is just 1, so you have no problem with that. Now there are 8 questions left, and then you have the right to, so in that exam you can actually answer 8 questions. So if you must answer the first 2, it means that you are left with, out of these 8, you have only 6 to pick from. So how many ways can you pick 6 questions out of 8? So you actually have 8 combinations, 6 ways, which is just 28. So our answer is C. An interval within which a root of this lies is, okay, how do I know? Just come over here. I've just drawn a small graph here. Look at this f of x. This is our f of x here. Now this is a, this is b, right? This is a particular interval. Now in between a and b, realize that f of x crosses the x-axis, right? So it means that this is a root. Because when you solve quadratic equation and I say f of x equals to 0, those factors of x that you have, those zeros are basically the roots of that function, of that equation, right? So you realize that if I had to know that the root lies between this interval a, b, then come here, come to a. How do I get f of a? I have to dot all the way to my f of x. So this is my f of a here. It's in the negative y-axis. So this f of a is negative. Now go over to b. How do I get f of b? I dot over to the f of x, and then I actually have my f of b up here. You realize that f of b is positive. So if there's a root in this interval a comma b, this closed interval, f of a must be opposite in sign to f of b, because that shows you then that the graph leaves from a and then crosses the x-axis all the way to get to f of b. You understand? Perfect. So you now realize that. How do we analyze that? Again, in mathematical language, I can just say f of a dot f of b is less than 0, right? Since one of them will be negative and the other one will be positive, you multiply negative and a positive number, it gives you a number that is less than 0. So f of 2, let's just pick a random interval here. Let's find f of 2. F of 2 is actually negative 4. All right. If f of 2 is negative 4, I want to get a number that would get this thing positive. That's the thing. If I get this one is too small. It's actually going to make this number negative again. So there's no point testing this one. Since f of 2 is already negative, I must test by this 3 layer like that, right? Because this 3 is so big that you can actually get the number to be positive now. Now f of 3 would now be what? 20, which is positive. So you realize f of 2 and f of 3, they have opposite signs. Hence, a root lies between 2 and 3. So your answer is just D. But then if you multiply those two together, and it's less than 0. So your answer is D, right? Starting with the initial value of x equals 1.5 using Newton-Raphson procedure once, an approximation to the root of this equals 0 is. Alright, so f of x is that. So f prime of x, we actually have to find that. So xn plus 1 is equals to xn minus f of xn over f prime of xn. Of course, that's a Newton-Raphson's iteration, right? So how do we get this, the first approximate, right? So you actually have xn plus 1 to be that original approximate, which is 1.5, minus f of 1.5 divided by f prime of 1.5. So we have to find f of 1.5 and f prime of 1.5, right? So f of 1.5, we put it in f of x, so we actually have 0.25. F prime of 1.5, we actually have put it here, we have 3. So xn plus 1 will be 1.5 minus 0.25 divided by 3, which gives us 1.417. So our answer is B. The domain of definition of the function f of x equals ln 5x minus 2 for x belonging to arrow is. Alright, so f of x is this, right? So what you want to get the domain here is basically, you know that log of a negative number does not exist. Take note, log of 0 does not exist either. You punch log 0 on your calculator, it gives you match error. So you actually take 5x minus 2, all of this guy like that must always be greater than 0. Strictly, right? So you actually have 5x minus 2 greater than 0. That's how you get the domain. So solve that inequality, you actually have x greater than 2 over 5. So it tells you that, of course, answer is C, right? X such that x greater than 2 over 5 for all x in R. Perfect. Alright guys, thank you so much for watching our video. We hope you enjoyed it, and we hope that by 12 p.m. in the night today we can actually bring up the other parts of the video so that you prepare very well for your maths. All the best. We're rooting for you. You have any difficulties, reach out to us. The contact on the previous screen. Thank you so much. Please share, like, comment, and subscribe.